graduates, obviously have to have an understanding of how the fluid mechanics works. And this is what it looks like. It's a glorified bathtub with a large motor around there which pumps water from this end, that end and back again. And we can put objects into the flow like that and see what happens to the flow around it. Now just doing it like this is not very informative. Obviously water is transparent, so we don't really get a full idea as to what's going on here. So we need some way of visualising the flow. We can do this by putting dye into the flow, something which is going to mark the flow and demonstrate where a particular piece of water is going. You can maybe see it from the ripples in the surface or little bits of dirt going past. And if we put some dye in there, it will really show up. There are lots of dyes we can use for this. Methyl blue, potassium permanganate, those show up quite well. The most spectacular thing to use, I think, is this, which is a fluorescent dye. If I switch the light, sit on there washing, and you can also see, because they put fluorescent dyes into that in order to make things look brighter and whiter, you can also see that this is fluorescing. The reason why it's fluorescing is that's a UV tube there, and I can now release fluorescent dye into the flow, and you can see where it goes.
It goes slowly.
I can let it go in little bursts, so I can let it go in continuously, and then, for example, this is a model of an aerofoil. I can see how the flow is going past the aerofoil and being deflected downwards. And I can understand more about it because if I, for example, increase the angle of attack, eventually I reach a point where instead of going around the aerofoil, the flow is getting pushed off like that. That aerofoil is now stalled. There is no lift force on it at all. So I can adjust it backwards and forwards. You can actually see the phenomenon of turbulence here as well. I've obviously got a fairly reasonable flow rate. If I was having water going past really slowly, the dye will come out in a nice, regular, straight line and remain straight. But it's not. The flow is much faster. It's full of little structures called turbulent eddies. And if I just remove that altogether, you can actually see how the dye is being moved around by the turbulent eddies. You're getting a diffusive effect. You're getting one effect of turbulence. You can obviously use different objects in here. That was an aerofoil. This is a cylinder. I can put that into the flow. And with a cylinder, you get what's referred to as vortex shedding. So you can see big eddies are being shed from alternate sides and then going downstream in a turbulent wake. And the fluid mechanics of this is the basis for a lot of engineering also in cars, aircraft and so forth, understanding what needs to go on there, what's going to happen to the air going around or water going around an object is the first step to actually engineering it better. Right, okay, in that case, if I will switch this off and take the next